An inductor coil of resistance 10 ohm and inductance 120 milliampere is connected across a battery of EMF 6 volt having as some internal resistance that is equals to 2 ohm. Fine, we have to calculate the charge that is flowing through the circuit. Now we know that during charging, current I is given by I naught 1 minus e to the power minus t by tau. Fine. Now this I can be written as dq by dt, that is I naught 1 minus e to the power minus t by tau. So dq is I naught 1 minus e to the power minus t by tau into dt. Now we have to calculate the charge that is flown, so I will integrate both the side so as to get the total charge that is flowing through the inductor. So Q comes out to be I naught 1 minus e to the power minus t by tau dt from, let's say, 0 to time t. So on integrating I get I naught out from the integration, so integration simply of 0 to t 1 minus e to the power minus t by tau dt. So I have integration of 1 as t and substituting the limits I have t minus 0 minus integration of this term, that is integration of e to the power minus t by tau. Now let's solve this integration separately. I have integration of minus t by tau from 0 to t, so it is given by e to the power minus t by tau into minus of 1 by tau, limit substituting from 0 to t. So it have minus tau into substituting the limit now, that is e to the power minus t by tau minus anything power 0 is 1. So this is t1 after substituting 0 over t. So the integration comes out to be tau e to the power minus, the 1 will be over here now, that is 1 minus e to the power minus t by tau. So substituting this integration in this equation, that is from 0 to t, I have I naught into t minus this integration is equals to tau into 1 minus e to the power minus t by tau. Fine, this is the total charge flowing through the inductor. Now in A case, that is at time 10 millisecond, we know tau is given by L by R, that is 120 into 10 to the power minus 3 by 10, that gives me 12 into 10 to the power minus 3. Fine. And in the second part, now we have to substitute all the values in this equation. Also I naught, that is the peak current flowing, will be equal to V upon my total resistance. So total resistance is given by 10 plus 2, because 2 is the internal resistance, 10 is the actual resistance that is applied, and V is 6, so it comes out to be 0.5 ampere. Right. Substituting all these values in this equation, I have Q as I naught, that is 0.5 into t is 110 millisecond, that is 10 into 10 to the power minus 3 minus tau of tau, that is given by 12 into 10 to the power minus 3 into 1 minus e to the power minus 100 into 10 to the power minus 3 divided by tau, that is 12 into 10 to the power minus 3. On solving this equation, I get the Q as 1.8 millicoulomb. So similarly for B and C part, where T is just replaced by 20 millisecond, I get Q as 5.6 millicoulomb, and in the C part, where time is again replaced by 100 millisecond, I have Q as 45 millicoulomb. That is the answer.